Have you ever wondered, are we living in a computer program? This is the big question that has been captivating the minds of philosophers, scientists, and even tech billionaires for quite some time now. It's a question that is as fascinating as it is perplexing. Welcome to the world of the simulation hypothesis, a proposition that suggests that all of reality as we know it, including the Earth and the universe, could in fact be an artificial simulation. It's like a cosmic version of the Matrix, but without the leather trench coats and slow-motion bullet dodges. Let's take a moment to think about this. It's not just a fanciful idea from the realm of science fiction. Some serious thinkers have given this concept a lot of thought. One of the most prominent among them is the philosopher Nick Bostrom. In the early 2000s, Bostrom proposed a trilemma that he called the simulation argument. It suggests that one of three unsettling scenarios must be true. Either humans go extinct before reaching a post-human stage. Any post-human civilization is extremely unlikely to run a significant number of simulations of their evolutionary history. Or we're almost certainly living in a computer simulation. Elon Musk, the visionary behind SpaceX and Tesla, is another believer in the simulation hypothesis. He once famously stated that there's a 1 in billions chance that we're not living in a simulation. The concept of ancestor simulation is central to this hypothesis. An advanced civilization with enormous computing power could potentially create a simulation of their ancestors. This simulated universe would be so intricately designed that the beings within it would have consciousness and believe in their reality. So here's the big question again. Is our reality nothing but a highly advanced computer simulation? Could we be like characters in a cosmic video game, blissfully unaware of our true nature? As mind-boggling as these ideas may seem, they're not beyond the realm of possibility. But to get to the bottom of this, we need to delve deeper into the numbers and data. Let's dive in. What are the odds, you ask? Let's crunch some numbers. Imagine the universe as a cosmic casino where the dice of destiny are constantly being rolled. This is where Nick Bostrom's trilemma comes into play. It's a philosophical conundrum that presents us with three possibilities. First, the human species is very likely to go extinct before reaching a post-human stage. Now, post-human refers to a stage of development at which we have the ability to run high-fidelity simulations of our ancestors. It's a future where our species has harnessed the power of the stars, tamed quantum mechanics, and turned our universe into a cosmic computer. But according to Bostrom, there is a high probability that we might never reach this stage. The second possibility is that any post-human civilization is extremely unlikely to run a significant number of simulations of their evolutionary history. This could be due to ethical considerations, resource constraints, or simply a lack of interest. The third and final possibility is the one that really gets the neurons firing. It suggests that we are almost certainly living in a computer simulation. It's a mind-boggling concept, isn't it? If the first two possibilities are not true, then this must be our reality. Now let's talk numbers. It's estimated that a post-human civilization could run about 10 to the power of 33 simulations concurrently, assuming only currently known methods of computation. That's a 1 followed by 33 zeros, a number so large it's hard to even fathom. If even a fraction of these post-humans decide to run ancestor simulations, the number of simulated realities would vastly outweigh the one base reality. Consequently, if we were to randomly pick a reality, the odds of it being a simulated one would be astronomically high. So the numbers suggest that either we are living in a simulation or humanity will cease to exist before reaching a post-human stage. Now let's talk tech. Can we create such advanced simulations? To simulate a universe so vast, so complex, teeming with billions of galaxies, stars, and planets, we need a computational powerhouse. Consider the human brain, the most sophisticated computer we know. It has about 100 billion neurons, each connected to about 10,000 others. That's 1,000 trillion connections, a number so staggering it makes our supercomputers look like calculators. Yet, we're making strides. Enter quantum computing, a field that's pushing the boundaries of what we thought was possible. Unlike classical computers that use bits as their smallest unit of information, quantum computers use quantum bits, or qubits. A qubit can be both a 0 and a 1 at the same time, thanks to a phenomenon called superposition. This allows quantum computers to process a vast number of possibilities all at once. If we take a look at Moore's law, it predicts that the number of transistors on a microchip doubles approximately every 2 years. This has held true for the past half-century, leading to an exponential increase in computing power. If this trend continues, we could see machines capable of simulations beyond our wildest dreams. But let's not get ahead of ourselves. Simulating a universe is no small feat. To simulate just 1 second of activity for every particle in the universe, it has been estimated that we would need a computer larger than the universe itself. And that's not taking into account the computing power needed to simulate consciousness, emotions, and all the nuances of human experience. Still, technology is advancing at breakneck speed. In the past 20 years alone, we've seen the rise of the internet, smartphones, and artificial intelligence. Who's to say what the next 20 or 200 or 2,000 years might bring? Given the pace of technological advancement, simulating a universe might not be a far-fetched idea. It's a mind-boggling concept, no doubt, but as we delve further into the realms of quantum computing and artificial intelligence, we might just find ourselves on the brink of a new reality, one where we are the creators of universes, not just observers. Let's take a look at our universe. Does it behave like a simulation? The fabric of our universe is woven with intriguing patterns that are reminiscent of a computer simulation. Consider the concept of Planck length and Planck time. The Planck length, about 25 orders of magnitude smaller than an atom, is the smallest measurement of length with any meaning. And Planck time, about 44 orders of magnitude shorter than a second, is the smallest measurement of time that has any meaning. Now, why does this matter? Well, these concepts suggest that our universe might be pixelated, much like a digital image. Just as a digital image is made up of individual pixels, the universe might be composed of discrete, indivisible units, but there's more. The weird and wonderful world of quantum mechanics offers further hints towards a simulated universe. Quantum phenomena, like the wave-particle duality and quantum entanglement, defy our everyday understanding of how the world should work. Take the wave-particle duality, for instance. Light behaves both as a particle and a wave, but only when we observe it. Until observed, it exists in a state of superposition, where it can be in all possible states at once. Strange, isn't it? Then there's quantum entanglement, where two particles become so intimately linked that the state of one instantly influences the state of the other, no matter how far apart they are. This spooky action at a distance, as Einstein called it, could be explained if our universe were a simulation, with the entangled particles connected by hidden variables in the underlying code. These are but a few tantalizing hints. The numbers, the data, all point towards a grand possibility. Of course, it's not definitive proof, but it's enough to make us wonder, to make us question the very nature of our reality. The universe in many ways behaves like a digital simulation. Living in a simulation, what does that mean for us? It's a question that triggers profound philosophical musings. If we do reside within a computer program, it throws our understanding of free will into disarray. Are our choices genuinely ours, or are they preordained by an unseen programmer? This question doesn't just challenge our personal autonomy, but it also shakes up our understanding of reality. Ponder this. If our universe is a simulation, then our reality is, in essence, a construct of information. It's like we're characters in a grand cosmic video game. This perspective reframes our understanding of existence, pushing us to consider reality from a digital rather than a physical standpoint. And while these implications may seem unsettling, they also inspire a sense of awe and curiosity. They push us to question, to explore, and to learn more about the world around us. Whether we are living in a simulation or not, the pursuit of this question has certainly expanded our understanding of reality.